Welcome back to College Algebra Basics, and today we're talking about thinking about decimals. And so what today's lesson is going to be, it's going to be some background information on how do we think about, how do we represent decimals, because our goal is to be able to efficiently add, subtract, multiply, and divide using decimal numbers. And this becomes very difficult if we don't have a really strong basis in which we understand what these decimals are and what they represent. First, a word of apology, and that is that I know today's class will feel kind of like we're going back to elementary school, and that's because in some ways we are. And let me say that I know that you are much more advanced in elementary school, and I know that you have a much stronger understanding than these things. I'm not trying to insult you, I'm not trying to belittle you, but I want to say that these ideas that showed up in elementary school are pivotal and essential to understanding how to work with decimals. And if you're struggling with decimals, it may be because you just need to remember, refresh, just bring these ideas back to the front of your mind so that you can use them as we think about adding, subtracting, and multiplying decimals. So let's start with a question. The question is just, we have a number, 135. The question is, what does it represent? I'll tell you what it doesn't represent. It doesn't represent three numbers, 1, 3, and 5, written in succession. I mean, I guess it actually does, I guess that actually is what it is, but in the world of mathematics, this number is much more rich than this, because this 1 doesn't mean 1, it means 100. This 3 doesn't mean 3, it means 30, and this 5, well, it does mean 5. But put them together, it doesn't mean 1, 3, and 5. It means 100, 3 tens, and 5 ones. You might remember at some point in your math career going through and illustrating these things. For example, you might see that the number 5 is illustrated with something along the lines of 5 individual green dots, just like we have here. Similarly, if we take 10 of these green dots and put them together, we get a 10, which might look something like this. And so you might notice that if we have this number, we had 5 green dots, we have 3 tens, and so we have 1, 2, 3 of these blue 10 sticks next to each other. And finally we have 100, and the 100 is obtained by putting 100 green blocks together, or putting 10 blue blocks together, and for me that's going to be this red block right here that has 100 on it. So now if you look, I've represented the number 135, and so to me this is what the number 135 means. As I start to write down the number, I start to think, well, I could, if I wanted, every single time I wanted to write this number down, I could draw some sort of stack or block of red things. So if I wanted, every time I write this number down, I could draw one big red block that has 100 things, and I'm going to just not do a great job with those dash lines there. And then I could say, well, I've got 3 10 blocks. 1, 2, 3 10 blocks. And I know there aren't 10 dashes here. That's because I'm being quick and lazy. And then I know that I have 5 of my 1 blocks. So I could, if I wanted, every time I had this number, I could try to draw these things down to represent this number. And in fact, in ancient times, before people developed the number systems, in fact, our numbering system wasn't developed until kind of the dark ages of European Enlightenment. It was developed in Arab or in kind of Persia and India and the Middle East and kind of that region of the world. While Europe was suffering the Dark Ages, that part of the world was actually an Enlightenment. They were the ones carrying forward the ideas the ideas of mathematics that we have today. I feel that the Middle Eastern mathematicians don't get near enough credit in today's curriculum or culture. But what they did is their numbering system is the one we got today. Before that, numbering systems mostly just tried to count how many dots you have. And so think about it, if you were an ancient person counting sheep on a hill and that was your job as a shepherd, you would just need a way of keeping track of sheep. So you might say, well, how many dots do I have? And you might just count the dots. Count your sheep and see if your sheep and your dots match up. And as your dots start to collect, you make bigger dots that represent groups of smaller ones. And then as those collect up, you make bigger groups of those bigger dots, and those are how they count up. The advancement, which occurred later, was to recognize that we can think of these dots in stacks. So we can think of these dots in stacks. And so if I come up with the number 135, then I can think, well, what does that number 135 represent? It means that I have 5 of these little green dots. So instead of drawing 5 dots, I'm going to just write the number 5. And instead of drawing 3 blue sticks, I'm just going to write the number 3. And instead of drawing, big red blocks, I'm just going to write the number 1. And then you see that if we think of these in columns, we notice that we have a ones column, a tens column, and a hundreds column. And our number 135 simply tells us how many ones we have, how many tens we have, and how many hundreds we have, and we group them all together to give us our number. But now, the rich question is, what happens when we want a number like 135.24? I realize that you probably understand this conversation about hundreds, tens, and ones, but the question is, what happens when we want to represent something that's a little more detailed, like this 135.24? What does this mean? What is this point, and what is this 2, and what does this 4 mean? Well, you probably already know. The 2 is what we call the tenths, and the 4 is what we call the hundredths. And going back to our representation, what we might see is that our 1 means we have 1 block of hundreds. So here's my 100 block. So our 1 means that we have 100 block. Our 3 means that we have 3 of these 10 blocks. And our 5 means that we have 5 of these 1 blocks. So I'll just put dots here. So that was our number, 135. But what if you have something that's smaller than a block? So what if we take these 5 blocks, what if we have a piece that's, instead of being the size of a block, what if that piece is just some smaller portion of the block, like say this purple strip right here that I'm trying to draw? How much is this little piece right here? Well, it turns out that strip is 1/10 of a block. And so we're going to put a decimal point and put a 1 for the 1/10 of a block spot. So we're going to say how many of those individual little strips do we have, and we are going to have 2 of them. So I'm going to draw 2 of those little tiny strips to make 2 little pieces that are each 1/10 the size of one of these blocks. Now, what does the 4 mean? What if we want to get even smaller? If we have pieces that are even smaller, you might take your block and separate it into pieces, and now what we might do is we might just block off a real tiny corner. And so what is that corner? That corner is 1/100th of a block. And so what we've done is we've divided our block up into tinier and tinier pieces. And notice that in this number, we're saying we have 2 of these 10 strips and 4 of these little 100 strips. And so what does our number 135.24 mean? It means we have 1 of these 100 blocks, 3 of these 10 blocks, 5 of these 1 blocks, 2 little strips that are each 1/10 the size of a block, and 4 of these tiny little corners that are each 1/100th of a block. And so you put them all together, and that gives you the number that we're trying to represent. Now I have a task for you. I would like you to build a representation of the number 217.86. So build a representation using these blocks, these red, blue, green, purple, and orange blocks and pieces of blocks that we've done so far. I'm going to ask you to pause your device, write down on your notes what you think the representation is, and then come back and we'll talk about what we think that answer is. Okay, we've unpaused our device. Hopefully we've worked hard on this question, And if you have, then I'm going to ask you, then we'll come back to this picture we have, and notice I take the same chart that we had earlier, except I've added to it, I'm going to take the same chart I've had earlier, except I've added to it a purple strip, which represents the number of purple items we have, and I've added to it an orange strip, which represents the number of little corners or 100ths that we have. And so we can see what our number represents. Our number represents 2 of these hundreds, represents 1 of these tens, represents 7 of these ones, 8 of these little purple strips, and 6 of these little orange corners. So what is that number? If I wanted to draw it, there are lots of ways I could do it, and there's not really a specific correct answer, but I was wanting you to think your way through this just for the sake of the problem. One way to do it would be to draw 2 of these big red blocks, to draw 1 of these 10 blocks, draw 7 individual green blocks, oh, that's 7, I don't need that one, draw 7 of those green blocks, and then finally let's draw 1 extra green block, and I'm going to put my purple strips on there, and so I've got 1/10, 2/10, 3/10, 4/10, 5/10, 6/10, up, I'm running out of space, 7/10, and 8/10, so it's like I have 8 little strips on there, and then I have 6 little 100 pieces. So that's really like we added 6 little squares on here. 1, 2, 3, 4, 5, 6. So this picture isn't the most beautiful that I've ever done, but I think you get the point across. I think it gets the point across that what we're doing representing is we're drawing the 100 blocks, we're drawing the 10 blocks, the 1 blocks, and then the tenths, and then the ones. Similarly, it might have been easier to draw this picture if we drew it over here and we drew our 6 little squares, like 1, 2, 3, 4, 5, 6. So maybe something like that looks a little bit better. So we have 8 of our strips and 6 of our individual blocks, and it gives us some idea of the size of our number. So you can see that the number 0.86, oh, I forgot my decimal point. Notice the decimal point always goes between the ones and the tenths and the hundredths. Note that we call this the tenths because it takes 10 of them to make 1. We call this the hundredths because it takes 100 orange blocks to make 1. So let's end the lesson there. Again, I'm not trying to insult you by doing things that are very simple that you've done for a long time. I'm just trying to refresh some of these ideas, because when it comes to the ideas of adding and subtracting decimals, it's important that we keep these ideas in mind. So good luck. Join me next time. We'll talk about adding decimals, and hopefully we'll really start to make a dent in understanding how to work with these things.